Section 2.8, page 1. We're now talking about linear approximations and differentials. So we've already seen that the tangent line is super close to the curve at that point where the line is officially tangent, right? Other sections of the curve, it could be far away. But now we want to see how we can use this tangent line to approximate other values on the curve, not on the tangent line, but where they land on the tangent line will approximate where they are on the curve. So what if you were asked to find the square root of 5 and you don't have your calculator? Do you just have it memorized? Probably not. So we want to pick a number that's super close to 5 that I know the square root of. For example, 4. I just know off the top of my head, as most people do, the square root of 4 equals 2. So we're going to use the tangent line to approximate on the curve the point of tangency. I'm messing up. So we want to find the tangent line for the square root function, and we're picking the input value of 4 because we know it, and that's to approximate 5. And again, we chose 4 because we knew it without a calculator. To create a tangent line, I need the equation of a line, which requires me to have x1, y1, and a slope. So starting with the points x1 and y1, we are picking x, we're not using 5. I can find y, the output, by plugging the input into the function, and so that output is my y value. Now, in terms of the slope of the tangent line, that's just the derivative of the original function. So taking the square root function and rewriting it to be an exponential variable, I can take the derivative by moving the exponent out front, subtracting 1, which really we would do the disguised form of 2 over 2, and I would end up getting, sorry, I was writing it down below, but if I had written 2 over 2 up here, that's where we get the negative 1/2 from. So I need to move the square root of x to the denominator, and now I'm plugging in the x value we have. With the square root of 4 being 2, I've got 1 over 2 times 2. I've got a slope of 1/4. So I can plug my x of 4, my y of 2, and my slope of 1/4 into the equation function, distribute the slope, add the 2, the opposite of 2 to both sides, so I've got y alone. I now have an equation of a tangent line, but we need to use that. So we're going to evaluate the tangent line at x equals 5 because it's going to be super close to the actual answer of the square root of 5. So taking this equation and plugging a 5 in, super easy math, right? This is really 5 over 1. I can take 5/4 plus 1 and rewrite 1 as denominator over denominator to keep its value of 1 so that I can add the numerators of matching denominator fractions. And 9/4 is a vague number. It's an actual number, but it doesn't necessarily mean a lot. So by dividing the top by the bottom, numerator by denominator, we find out that 9/4 is exactly 2.25. So our approximation is 2.25. But if you got out a calculator and typed in the square root of 5, it's going to keep going in terms of decimals. But since our actual answer went to the 10/100th spot, if we rounded this at the 100th spot, we would end up with 2.24. So our approximation is pretty close. Here's a visual of what happened. We start with the square root function, which is this orange equation that looks like this. We want to see where x equals 5 is on the graph, but I don't know the square root of 5 off the top of my head, whereas I do know the square root of 4. So here is the height of 4 with an output of 2. This is where we centered our tangent line. We could have put a tangent line here. We could have put a tangent line here. But if we want 5, we want a tangent line somewhere close to it. I don't know the square root of 6, but I do know the square root of 4. So we centered this tangent line At 4, we mathematically found the tangent line, and it's hard to see the way I drew this, but if we could have plugged 5 into the orange function, square root of 5 into the square root function, on the orange line, we would see we get 2.24 out. And I said exactly, obviously that's a rounded exact answer. But on the tangent line, we found when we plugged it in, actually a quarter over 2, which would be a little bit higher, we got 2.25. So we didn't know the square root of 5, but we took the 4, and since square root of 5 is going to be bigger than square root of 4, I expected an answer bigger than 2, and I used the tangent line, whose math was much easier than I could have without a calculator.